Hello, and welcome to Tomversations, a semi-regular conversation with me, your host, Tom Hollingsworth, the networking nerd, on a variety of technical subjects. Today I'd like to talk about networking, and I would like to zero in on the internet. Now we all know that logically, packets flow from point A to point B. However, due to the way that the internet uses decentralized routing, sometimes they have to flow through C, D, E, and many other networks to arrive at their destination. This is just something that we have grown accustomed to and accepted. However, one thing that is causing problems in the internet is the rise of so-called middleboxes. The term was coined in 1999, and it refers to a variety of network appliances that are inline in the packet transit path that do a variety of things. Now, these can be boxes that support things like network address translation, firewalls, deep packet inspection, or application delivery controllers, also called load balancers. Odds are extremely good that as you're watching this video, the packets that are traversing from the video site to your laptop or your mobile device have gone through a multitude of these middle boxes. They're good, right? They help us do things like stay secure, provide additional address space on the internet, and possibly even route traffic based on a variety of other characteristics. Well, in theory, you're absolutely right. In practice, these middle boxes do tend to get in the way quite a bit. The biggest complaint is that middle boxes break applications. They make it very difficult to do even simple things like fragmenting packets for networks of varying maximum transmission unit or MTU size. Causing problems with packet fragmentation makes it difficult to set up a path that allows big packets to be traversing the network. You often have to play with the lowest common denominator, and that's often determined by a middle box. Because of the insertion of middle boxes, applications aren't truly end-to-end anymore, and a failure or slowdown of any one of these boxes in the middle of the packet path can have adverse effects on application performance, and you can't do anything about it because your application still thinks that it's talking from point A to point B, and it can't see network C, D, and E, or middle boxes F, G, and H in the middle, and it can't accommodate for their performance variations. And that's assuming boxes are even working the way that you want them to. Think about something more complicated, like middle boxes that are in use for things like traffic shaping. Maybe those middle boxes are terminating long-lived flows to recycle things like network address translation address space. Well, that's great if you are using very short-lived browsers with TCP retransmissions. But what about things like push email or instant messaging? Those are long-lived flows that I really wish that they would stay up much longer. Can't really do anything about that if you don't control the middle boxes. And lastly, middle boxes, while they work really well for protocols that we know and love, like TCP and UDP, they have a really hard time understanding new protocols, even ones built on this. Things like Session Initiation Protocol, or SIP, have been adversely affected to the point where many voice over IP providers, which should have been using SIP all of this time, haven't because they can't work around the middle box problem. So middle boxes break applications, and we can't do anything about them. And we really wish that we could make things run faster. So how do we do that? Well, there has been a cottage industry that has arisen around the idea of accelerating traffic around these middle boxes. Now, sometimes that takes the form of new protocols like Google's Quick that are attempting to replicate a lot of the functionality that we find in secure TCP transmissions using things like UDP and multiplexing streams. And Quick has caught on from the original definition in Google's Chromium Labs to be something that's being heavily adopted, especially by Google services. But not everyone has the opportunity or the money to run their application over Quick. And so they turn to a group of providers which can help out with that. The first group is dedicated to offering application acceleration through the middle of the network. You're probably familiar with companies like Teridion or even mode that are offering a private network that allows you to connect your traffic to a essentially point of presence, and then your traffic will traverse the provider's network free of Middleboxes and exit somewhere on the other side, hopefully close to wherever it needs to be. Now, that works great in theory. First, you're going to have to pay for that network. And second, if you're using an application that is maybe not standard or possibly even widely adopted, you're just going to have to hope that the transit provider is capable of passing that traffic along as fast as you would like. It does do a great job of avoiding middleware boxes. However, are you sure that their traffic isn't being affected adversely in other ways? It's a difficult question to answer, and your provider may or may not be able to tell you that. That's the model as a service. Maybe you're someone who's a little bit more of a tinkerer, and you're saying to yourself, well, maybe I can do this myself. That's where SD-WAN providers come in. We've talked about SD-WAN a lot in these video series, and how there are providers who provide their own hardware for you to build your own SD-WAN wherever you want to go. And there have been new providers, such as Ariaka and Adaptive Networks, that provide their own SD-WAN network for you to use. Now, these providers are offering a very similar service to those of Teridion and Mode, but more focused on the SD-WAN side of hardware. As a matter of fact, Mode's service partners with SD-WAN providers to provide an on-ramp to the existing network that Mode has provided. But with companies like Ariaka and Adaptive, you can build your own on-ramp to their network, completely free of any middleware boxes, because you're using secured tunnels to transmit traffic back and forth. In theory, that sounds great, provided you're ready to make the jump to SD-WAN, and you're willing to pay these companies to provide the network, as opposed to building your own SD-WAN. So here's the 64,000-bit question. Does it work? Well, that's a good question. And the answers are kind of hard to come by, because for first things first, the network that you are traversing, whether it's Teridion or Mode or Ariaka or Adaptive, is kind of a black box. I mean, once the packets go in one side, they come out the other, but we don't know which way they went. It's not unlike an MPLS circuit-based network where there are paths that are built and your packets come out the other side, but good luck where they come out, which raises questions around things like data governance and security. Can you tell your provider that you want packets to follow a certain path through their network? Well, I suppose you could make that request, but if the provider doesn't have any way of pathing those circuits out themselves, they may not be able to fulfill the request, or they may be unwilling. That's something that happens quite frequently. We know which way your packets need to go in order to provide the best performance. Don't tell us how to do our jobs. Perhaps you can't even tell them how to do their jobs because there's an algorithm making that decision, using things like low-cost circuits at certain times of the day, or using heavily traversed circuits that are capable of taking a lot of traffic. So you may not even be able to influence the path selection to take a certain network, or to avoid certain networks. As political pressures tend to mount in countries around the world, laws are passed, regulations are created that dissuade or outright outlaw packets from traversing certain networks. We have seen issues with US traffic not being allowed to traverse through Chinese networks. We have seen instances of BGP hijacks forcing large amounts of traffic through servers in Russia and other countries in the world. And if you live in a country like Germany, who has some of the most strict data laws on the books, your packets may not even be allowed to leave the country. How can you prove that? You're probably thinking to yourself, well, maybe it doesn't matter until an auditor is barking up your tree, in which case you really want to be able to provide the reports that they're asking for. Another issue is the guarantee that you actually are avoiding Middleboxes. Sure, you're probably sending traffic onto these networks and it's coming out the other side, and your users are fairly happy because through the use of things like SSL encryption or IPsec VPNs, you know that it's not being messed with because it's all encrypted. However, when the traffic hits the terminal point on the other side, you can't guarantee that it's not going to go through some middleware boxes before it arrives at your users' hands. And I say hands specifically because mobile networks are considered some of the worst offenders of middleware boxes for things like traffic shaping and reducing packet sizes for mobile handsets, or reducing traffic load on mobile cell towers. In fact, AT&T and Verizon, two of the largest mobile providers in the US and indeed in the world, are notorious for having some of the most opaque middle boxes out there. So if you can't see it on their network, how can you guarantee you're not being affected by it? Even if your solution, whether it be application focused or SD-WAN focused, is avoiding those boxes. Through all of these questions, through all of this implementation, and through all of the money that you're paying for these services, what exactly are you gaining in the long run? You gaining super increased performance? How much is super? 20%? 40%? Odds are good you're not getting anywhere close to that. Maybe 10% is all you need. But is the 10% performance increase that you're seeing for your user base outweighing the cash or capital outlay that you need to build these networks or pay someone else to operate them for you? It's a very tough business decision that needs to be made. And if all of the applications are running in the cloud anyway, are you really doing that much good? Because a lot of the middleware boxes that we see now are optimized for delivering traffic as fast as they can from the cloud. So if your users are all in an office talking to another office, but the application they're using to talk is in the cloud, you may not be gaining nearly as many advantages as you think. So what's the answer, ultimately? Well, the answer is you need to know what your application has to do. You need to understand how your users are capable of tolerating things like delays, TCP resets, and other issues. And you have to be willing to examine all the available options, whether they are just deal with it, I'm going to pay this service to take care of it for me, or I'm going to build out a network that allows me to do this in a much better way. And you're going to have to spend time and money doing the research, building the proof of concepts, and evaluating whether or not the money that you're going to be spending is worth it for the users who are using your application. The answer may be yes, and it could be a slam dunk, and the answer could very well be no, and it's back to the drawing board. The truth lies somewhere in the middle. That should just about do it for this episode of Tomversations. Thank you very much for joining me today. I hope you liked this and other videos that we have posted here on the channel. You are probably seeing a couple of them floating around my head right now. Some great videos from our website at gestaltit.com, where we have the Checksum video series, the On-Premise IT Roundtable podcast, and the weekly Rundown news show. Hope that you can join me for another great episode of Tomversations in the future. And thank you very much for watching.